count from 0 to 15. I want to write it again, and I'm going to write the small one so I can replace it. Okay, so we've got a K-map and we've got just two inputs. Then they're going to be X and Y. Okay? What are the possible values for X? 0 and 1. Possible values of Y are 0 and 1, right? So if we look at it as a grid, then this represents 0, 0, right? This would be 0, X is 0. This is where X is 0, Y is 0. This is where X is 1, Y is 0. This is where Y is 1, X is 0, and then there's 1, 1. All right. So let's say we had an expression F equals to XY plus X not Y or not X, Y. Can this be simplified? Yes. Simplifies to what? See, a little kind of
The first one you get X.
X or not X, Y.
No, you get X multiplied by 1, because you get Y plus not Y is 1. And then plus X not X, Y.
Let's look at an easier way. Yeah, see, you still kind of, maybe this, maybe that, because, you know, obviously if we go out and plot through the boolean algebra, we'll get to a solution. But the point is to really show this graphical solution. So let's see this. This one is when, this is XY. So we'll go to this table, we'll put a 1 where that exists. This is a min term, right? Talking about and. This is obviously a sum products. Sum of products expression. So this min term is X equals 1, Y, where X and Y are 1. So that's this one. And if we're talking about min terms, we want X and Y to become 1. So the and, when we and these together, we're supposed to get a 1. So we go to the table and we put a 1 in there. So this is where X is 1, Y is 1, and the result is supposed to be a 1. That's why I put a 1 in there to designate sum of products. This is X is 1, Y is 0. So that's 1, 0. So we put 1 there. Finally, this is, I might have done that.
Yeah, why are there 2 1 zeros?
Why are there 2 1 zeros? There shouldn't be 2 1 zeros.
Should be 0
This
1.
should be 0. That's supposed to be 1 0. Yeah. This is 1 0. That's X
0 1.
This is X
1 0 1.
How do I want to see this? This should be, let's get this
1
one.
0.
I want, this is X, and so it's XY. So this is going to be 0 1. This is going to be 1 0. Yeah, okay. Okay, so there's our other term. So here's 0 1. This one's 1 0. Now, in the preceding slides, we're going to talk about how we get to these. But graphically, what we can then do is group the ones together in pairs, in multiples of, in powers of 2. We can group them in 2s, 4s, 8s, 16s, 32s, so on and so forth, or any number thereof. So we can group these two together. And then we can group these two together. As a result of this, we now can see what we can now find a simplified expression. simplified expression from this table becomes x or y. Becomes x or y, because if we look along this column, what we would have, if we look at these, when we group these two terms together, we would end up, looking at these two terms, we would have, let's see, we would have x, not y, or x, y. What does that give us? That gives us x. No problem, right? If we look at these two grouped together, what we then have is not x, y, or x, y, which gives us
Y.
oh, do we feel the power now? So immediately we're able to go from this graphical method to a simplified expression with very little guesswork, right? So all we have to do now is learn exactly how to do these groupings and what makes it, to get this correct. And the solution we can read directly from the graph, from the table. Okay? So that's what, so when we make the larger